Okay, folks, welcome to my first podcast. Today we're going to be looking at position time graphs, and we're going to be actually analyzing the motion of different objects and relating that to position time graphs. So we're going to be looking here at our first example, and it's going to be this vehicle over here. We're going to call it car 1. And if you look carefully, you'll notice that in every second, 1 second interval, this vehicle travels 1 meter, and it's traveling 1 meter to the east. So we can say that it has a constant motion or a uniform motion. So we can write that over here. So constant velocity, or sometimes we'll say uniform motion. And the reason it's uniform is because, again, it's traveling the same distance, or it has the same change in position every second. Now when we graph this on the position time graph, you want to make sure when you look at the position time graph, you always look at the direction that's positive. So east would be positive in this case, and west would be our negative position. So when you have a negative number, it really represents west. So we're going to start off over here by looking at our first time. So at 0 seconds over here, you can see that my vehicle is exactly at 0 meters east. It's starting at the reference point, in other words. Then we'll look at 1 second. It's going to be at 1 meter east. At 2 seconds, it's going to be 2 meters east. 3 seconds, it's going to be 3 meters east. I think you get the idea here that we do, in fact, have a consistent motion. And you can see that when we look at the change in position every second, I'm increasing or changing my motion, my position, by 1 meter towards the east. So I can see that I've got a velocity, a constant velocity of 1 meter per second towards the east. And when I draw a line of best fit here, sketch it out over here, you can see it's a nice straight line of best fit, indicating that there is in fact a uniform motion. Now the next graph is a little different in that the vehicle is moving the opposite way. It's moving towards the west. How do we know? Well, we look at 0 time. We're going to be over on this side here, and what happens is, just excuse me for a bit. Where are we here? Design, layout, oops. Oh yeah, review. Sorry about that. So in this case, we're starting over here. So we're starting at this point, and gradually we're changing our position, so it's moving towards the west. Now in this case, for every 1 second interval, we're actually moving 2 meters negatively, or 2 meters towards the west. So in other words, my velocity here would be 2 meters per second westward. And for the description of motion, again, we have a constant change. So every second, we'll have the same change in position. So I can say I got a constant velocity, and my velocity is 2 meters per second towards the west. We also say that this is a uniform motion. It's not changing. And similarly, like before, if I was to graph my motion, I would graph the position with time. So at 0 seconds over here, we're going to be 6 meters east, so I'd be up here. At 1 second, I'm going to be at 4 meters east. At 2 seconds, it'll be 2 meters east. At 3 seconds, I'm right at the reference point at 0. And at 4 seconds over here, we're going to be at negative 2 meters east, or 2 meters west of the reference point. So you can see here, like before, we have a nice constant change in position. In each case, every second, we're moving 2 meters. So in other words, my velocity again is 2 meters per second west. And if I draw a line of best fit, I would draw a nice straight line, and this time it's going downwards, which indicates that the object was traveling westward. Now the last object we're going to be looking at is a little different in that, in this case, the object is at the same position. So it's not changing its motion. So every time interval, it's at the same location. It's always at 1 meters east. So we say that the object would be motionless. So it's a motionless object. And if I was to draw a position time graph of the motion, you'd see that the position is always at 1 meter. So at 0 it's there, 1 second it's there, 2 seconds, 3 seconds. In other words, the same position. It's an unchanging position. So constant position. So it's a motionless object. So I'm going to write that over here. Constant position. Therefore, it is a motionless object. So in each situation, you saw we have a nice straight line, and the object is either not moving or has a constant motion. I think we'll end here for now.